Hi, in this video we are going to identify four distinct types of artificial intelligence: reactive machines, limited memory, theory of mind, and self-aware machines. But first, let's identify what artificial intelligence is and techniques used in developing artificial intelligence systems. What is artificial intelligence? AI. Artificial intelligence is a branch of computer science that attempts to replicate or simulate human intelligence in a machine. So, machines can perform tasks that typically require human intelligence. Programmable functions of artificial intelligence systems include planning, learning, reasoning, problem solving, and decision making. Artificial intelligence systems are powered by algorithms using techniques such as machine learning, deep learning, and rules, where machine learning algorithms feed computer data to artificial intelligence systems using statistical techniques to enable AI systems to learn. Through machine learning, AI systems get progressively better at tasks without having to be specifically programmed to do so. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. The process of learning begins with observations of data, such as exams, direct experience, or instructions, in order to look for patterns in data and make better decisions in the future based on the exams that we provide. Thus, the aim is to allow the computers to learn automatically without human intervention or assistance and adjust actions accordingly. Machine learning uses algorithms that are categorized as supervised, unsupervised, semi-supervised, and reinforcement. Supervised machine learning algorithms. These algorithms can apply what has been learned in the past to new data using labeled exams to predict future events. Starting from the analysis of a known training dataset, the learning algorithm produces an inferred function to make prediction about the output values. The concept of this learning focuses on labeling of training data. So the model first learns from the given data, where the training data contains different patterns which the model will learn. In other words, the outputs are already available, but for a collection of data, various outputs are there. Supervising here means helping out the model to predict the right things. The data will contain inputs with corresponding outputs. This has hidden pattern in it. The algorithm will learn these patterns and will try to apply the same knowledge to unseen data. Thus, the aim is to predict future values. And in case of supervised learning, the system has both the inputs and the outputs. So depending on the difference between the desired output and the observed output, the system is set to learn and improve. Unsupervised machine learning algorithms. These algorithms are used when the information used to train is neither classified nor labeled. Supervised learning studies how systems can infer a function to describe a hidden structure from unlabeled data. So the system doesn't figure out the right output, but it explores the data and can draw inferences from datasets to describe hidden structures from unlabeled data. Supervised machine learning helps you find unknown pattern in data where the users do not need to supervise the model. Instead, it allows the model to work on its own to discover patterns and information that was previously undetected. It mainly deals with unlabeled data. Because unsupervised learning algorithms are used against data which is not labeled, anomaly detection can discover important data points in your data set, which is useful for finding fraudulent transactions. For unsupervised learning algorithms, the artificial intelligence system is presented with an unlabeled and uncategorized dataset. Thus, the system hasn't undergone any prior training. So, unsupervised learning can be thought of as learning without a teacher. In this case, supervised learning, the system only has inputs and no outputs. Supervised learning comes in extremely helpful during the tasks associated with data mining and feature extraction, where the ultimate goal of unsupervised learning is to discover hidden trends and patterns in the data or to extract desired features. Supervised learning only deals with the input data set without any prior knowledge or learning. Semi-supervised machine learning algorithm. These algorithms fall somewhere in between supervised and unsupervised learning, since they use both labeled and unlabeled data for training. The systems that use this method are able to considerably improve learning accuracy. Usually, semi-supervised learning is chosen when the acquired labeled data requires skilled and relevant resources in order to train or learn from it. Otherwise, acquiring unlabeled data generally doesn't require additional resources. Reinforcement machine learning algorithms. Reinforcement machine learning is a learning method that interacts with its environment by producing actions and discovers errors or rewards. Trial and error search and delayed reward are the most relevant characteristics of reinforcement learning. This method allows machines and software agents to automatically determine the ideal behavior within a specific context in order to maximize its performance. Simple reward feedback is required for the agent to learn which action is best. This is known as the reinforcement signal. Now, let's take a look at what do we mean by deep learning. What is deep learning? Deep learning is an artificial intelligence function that imitates the working of the human brain in processing data and creating patterns for use in decision making. Deep learning is a subset of machine learning in artificial intelligence that has networks capable of learning unsupervised from data that is unstructured or unlabeled. This function mimics the work of human brain in processing data for use in detecting objects, recognizing speech, translating languages, and making decisions. Deep learning is able to learn without human supervision, drawing from data that is both unstructured and unlabeled. It can be used to help detect fraud or money laundering, among other functions. Machine learning in general uses algorithms developed for specific tasks. In deep learning, it is more of a data representation based upon multiple layers of a matrix where each layer uses output from the previous layer as input. It is more of mathematical distribution for complex behavior. Deep learning simply is learning from examples. At a very basic level, deep learning is a machine learning technique. It teaches a computer to filter inputs through layers to learn how to predict and classify information. Observations can be in the form of images, text, or sound. The inspiration for deep learning is the way that the human brain filters information. Its purpose is to mimic how the human brain works to create some real magic. We can classify artificial intelligence into four distinct types: reactive machines, limited memory, theory of mind, and self-aware. First, reactive machines. Reactive machines are the most basic types of artificial intelligence. These machines only focus on current scenarios and react on it as per possible best action. Such artificial intelligence systems do not store memories or past experience for future actions. Examples of reactive machines are IBM's Deep Blue system and Google's AlphaGo. These systems only comprehends and acts on the presently existing world and components within it. To simplify, reactive machines are programmed in a way that no matter the time or place, these machines will always behave the way they were programmed. For example, Deep Blue was created to play chess against a human competitor with intent to defeat the competitor. It was programmed with the ability to identify chessboard and its pieces while understanding the pieces' functions. Deep Blue could make predictions about what moves it should make and the moves its opponent might make. These thus having an enhanced ability to predict, select, and win. Such a system became the first computerized program to defeat a human opponent. Next, limited memory. Limited memory machines can store past experience or some data for a short period of time. These machines can use stored data for a limited time period only. Self-driving cars are one of the best examples of limited memory systems. These cars can store recent speed of nearby cars, the distance of other cars, speed limit, and other information to navigate the road. Limited memory is comprised of machine learning models that derive knowledge from previously learned information, stored data, or events. Unlike reactive machines, limited memory learns from the past by observing actions or data fed to them in order to build experiential knowledge. Self-driving cars use the principle of limited memory in that they depend on a combination of observational and pre-programmed knowledge to observe and understand how to properly drive and function among human-dependent vehicles. Self-driving cars read their environment, detect patterns or changes in external factors, and adjust as necessary. They also observe the movement of other vehicles and people in their line of vision. Theory of mind. Theory of mind artificial intelligence should understand the human emotions, people, beliefs, and can interact socially like humans. This type of artificial intelligence machines are still not fully developed, but researchers are making lots of efforts and improvements for developing such artificial intelligence machines. What constitutes theory of mind is decision-making ability equal to the extent of a human mind, but by machines. While there are some machines that currently exhibit human-like capabilities, voice assistants for instance, none are fully capable of holding conversations relative to human standards. One component of human conversation is having emotional capacity or sounding and behaving like a person would in standard conventions of conversation. This future class of machine ability would include understanding that people have thoughts and emotions that affect behavioral output and thus influence a theory of mind machine's thought process. Social interaction is a key aspect of human interaction, so to make theory of mind machines tangible, the artificial intelligence systems that control the now hypothetical machines would have to identify, understand, retain, and remember emotional output and behaviors while knowing how to respond to them. Theory of mind machines would have to be able to use the information derived from people and adapt it into their learning models to know how to communicate with and treat different situations. Theory of mind is a highly advanced form of proposed artificial intelligence that would require machines to thoroughly acknowledge rapid shifts in emotional and behavioral patterns in humans and also understand that human behavior is subject to change. Thus, theory of mind machines would have to be able to learn rapidly at a moment's notice. Some elements of theory of mind artificial intelligence currently exist or have existed in recent past, where two notable examples are the robot Kismet and Sophia, created while neither fully holds the ability to have matured human conversation with an actual person. Both robots have aspects of emotive ability similar to that of humans, where theory of mind only focuses on the aspect of comprehension and replication of human practices. Next, self-awareness AI is the future of artificial intelligence. These machines will be super intelligent and will have their own consciousness, sentiments, and self-awareness. These machines will be smarter than human mind. Self-awareness artificial intelligence doesn't exist in reality still, and it is a hypothetical concept. Self-aware artificial intelligence involves machines that have human-level consciousness. This form of artificial intelligence is not currently in existence, but would be considered the most advanced form of artificial intelligence known to man. These include the ability to not only recognize and replicate human-like actions, but also to think for itself, have desires, and understand its feelings. Self-aware artificial intelligence, in essence, is an advancement and extension of theory of mind. It takes it a step further by implying that it can and will have self-guided thoughts and reactions.